We destroyed this build plate trying to automate the H series. Nobody has automated the H2D, H2S or the H2C before, and apparently there's a reason. We had to throw out our entire P and X series design, redo the scraper 3 times and break a few things along the way. But what we ended up with is the most advanced FarmLoop system we've ever built. In this video I will show you a tricky design that made stage 1 possible, and why our first stage 2 concepts completely failed. And in the end, we even made our farm board talk to the printer. If you're new here, I'm Jan. Together with my best friend, we run a 40 printer farm in Switzerland, and we've shipped over 20,000 products from the most expensive country in the world. That's only possible thanks to automation. Let's dive in. First, let's have a look at stage 1. It had 2 major problems that required tricky solutions. Problem number 1 is missing mounting points. We initially thought we could take the X and P series design, make it a bit bigger and apply it to the H series. However, we discovered quickly that the H series was not designed with any edge to lean against, making our bender unstable. There were no mounting holes, no edge and no slots. This forced us to find a new approach. We noticed that the bed itself had many features, which were not present on the P and X series. Instead of mounting the bender below the print bed, we started clipping it directly to the bed. The result was a piston mechanism that could be installed in seconds, which bends the plate and releases the print. This works the same on all H series printers. But what does not work well on all 3 printers is the scraper. The print head is obviously different on all of them. H2S with 1 nozzle, H2D with 2, and then H2C with the exchangeable nozzles. We went through multiple iterations, failing and redesigning, until we finally got different scrapers that work with each of the printers. At least the bed clips work consistently across all H series printers. Stage 1 works well for small to medium prints, but it hits limitations when printing large objects or parts that stick strongly to the bed. That's also how we destroyed our build plate. Stage 1 uses passive bending, and this introduces 2 major issues. The first is height. Increasing the bender height reduces the maximum printable Z height. A 50mm bender, for example, reduces the printable height by 50. The second issue is more dangerous. Pushing the bender too hard can cause the Z-axis to skip under load. And when that happens, the printer loses track on where the bed actually is. Then, during the push routine, the plate moves too close to the nozzle, which can result in a scratched build plate. In the worst case, the plate is destroyed. We tested and found that 50mm of push height is the sweet spot. Anything more than that increased the risk of failure. But 50mm of passive bending is usually not enough to clear large parts on this large plate. That's where stage 2 comes in. We replaced the 50mm passive bender with the 75mm actuator. Since the actuator engages only when the print is finished, the Z-axis remains locked in place. This eliminates skipping and therefore plate damage. We regained the full Z height of the H series, allowing us to print to the maximum height. Exactly why you bought the H series. But there was still one final challenge. A single actuator on one side could not bend the entire build plate. Even with active bending at 75mm, the opposite side of the plate barely flexed, leaving parts at the far edge stuck. The solution was simple: add a second actuator on the other side. But here's where we got a bit over-engineered. What if the 2 actuators didn't fire together? What if they fire independently at different stroke length and different timings to send a wave across the plate? That's why we call it wave bending. 2 actuators firing out of sync, producing a wave that travels across the plate. Parts that survive the one-sided bend can't survive a wave. This is the part that is unique to the stage 2 of the H series. It didn't exist before, not in any printer we know. Now there's one more problem we had to solve. Let's say you're running fully automated, but somehow the limit switch is not giving the right triggers to the farm board, and the door does not open after the print is finished. The part will be pushed against the door. At least with SimplyPrint's bed check AI, we can detect the issue and the next print will not start. But this is still a case that should not happen. So we did something special here. We connected our FarmLoop system directly to the printer over MQTT. Now our system knows when the print starts and when it finishes. So closing and opening the door happens automatically, and we're not fully dependent on the limit switch anymore. And we're working hard to integrate all triggers with MQTT in future. And for the hundreds of users of stage 2, you will be only one firmware upgrade away. This way, even if the limit switch fails, the system will run reliably overnight and over the weekend. And with all these features, you can finally enter mass production with your H series. 3 machines, fully unattended, injecting parts 24/7. We have tested a lot and it was quite a journey to get here. But now we're excited to release Stage 1 and Stage 2. Stage 1 hardware is free on MakerWord, Stage 2 kit is available now. Limited quantity, first come, first serve. And personally, I'm really excited to get your feedback on them. And something you've been waiting for, the giveaway. Simplyprint is now officially supporting FarmLoop in their farm management software. To celebrate, we're giving away a brand new X2D, including FarmLoop and Simplyprint's annual subscription plan. Check our Instagram on how to enter the giveaway. The link is in the description below. And until then, happy looping, 3D farmers.